Welcome. Today, we explore robust strategies for ingesting data into Hadoop Distributed File System or HDFS using three pivotal tools: Apache Flume, Apache Sqoop, and Apache Kafka. We'll compare streaming, batch, and real-time pipelines, and demonstrate how these solutions conquer scalability, reliability, and latency challenges in big data ecosystems. Data ingestion is the foundation of big data processing. It involves moving heterogeneous data from application locks, databases, and external systems into centralized storage like HDFS. Key challenges include scaling to handle massive volumes, ensuring reliability during transfer, minimizing latency, and managing format mismatches. Why HDFS? It delivers distributed, fault-tolerant storage optimized for horizontal scaling, making it ideal for petabyte-scale analytics workloads. Apache Flume Flume specializes in high-volume streaming data ingestion. Think log files, clickstream events, or sensor telemetry. Its architecture features three core components: sources ingest data via methods like TAIL-F or HTTP. Channels act as buffers, either memory-based for speed or file-based for durability. Sinks then export data to destinations like HDFS, HBase, or Kafka. This decoupled design ensures continuous flow, even during backend failures. Flume's strengths: simplicity, scalability, and built-in fault tolerance. Configuration is declarative. For example, to write to HDFS, we define the sink type as HDFS, the path with time-based partitions like HDFS://nameit/path/%y-%m-%d, and file rollover every 3,600 seconds. A common use case: real-time log aggregation, where Flume tails web server logs and writes them directly to HDFS in compressed partition directories. Apache Sqoop Sqoop handles bulk batch transfers between relational databases and HDFS. It efficiently converts stable rows into HDFS file formats like Parquet, Avro, or CSV. Under the hood, Sqoop parallelizes workloads using MapReduce, enabling high-speed imports or exports. For instance, a billion-row table can be split across multiple mappers, each writing to partition HDFS paths. Sqoop operates via simple CLI commands. To import MySQL table as Parquet, Sqoop import -- as Parquet file. To export data back to the database, Sqoop export. A classic use case: nightly synchronization of transactional data from MySQL to HDFS, enabling next-day analytics without impacting alt systems. Note: always use -- split by to distribute load evenly across database shards. Apache Kafka is the backbone of real-time streaming pipelines. Producers publish event streams to categorize channels called topics. Consumers subscribe to topics for processing. Workers Kafka's distributed servers orchestrate this flow with millisecond latency. Unlike Flume or Sqoop, Kafka acts as a high-throughput buffer, decoupling producers from consumers. This enables complex architectures like multi-subscriber analytics or microservices integration. To land Kafka streams in HDFS, we use Kafka Connect. Its HDFS sync connector writes topics to HDFS in formats like Avro or Parquet, with critical features: partition mapping, schema evolution, and exactly once delivery guarantees. Configuration requires setting the connector class HDFS URL like HDFS://nanerd:8020 and format class. Ideal for clickstream analytics, user actions stream via Kafka and persist in query-ready HDFS directories partitioned by event time. Choosing the right tool depends on data type and latency needs. Flume excels at simple, second latency log streaming to HDFS, but lacks SQL support. Sqoop handles hour-long batch transfers with schema awareness, yet isn't real-time. Kafka delivers millisecond latency streams, but requires connectors for HDFS. Pro tip: combine them. A hybrid pipeline like Flume to Kafka to HDFS leverages Kafka's queuing for back pressure handling before Connect writes to storage. Follow these best practices. For Flume, use file channels for crash recovery, compress outputs with gzip. For Sqoop, leverage -- split by for parallelism. Prefer Parquet for columnar efficiency. For Kafka, adopt schema registries for compatibility, monitor consumer lag. For HDFS, partition by date/time, use Parquet or ORC formats for storage optimization. Together, these prevent data loss, reduce costs, and accelerate queries. In summary, Flume streams logs to HDFS. Sqoop batches database snapshots. Kafka fuels real-time pipelines via Connect. But the true power lies in integration. Combine Flume or Kafka for streaming with Sqoop for bulk loads to build comprehensive ingestion frameworks. This equips organizations to handle any data velocity, volume, or variety. Thank you.